In this video, we will look at the synchronous queue. Synchronous queue is blocking queue in which each insert operation must wait for a corresponding remove operation by another thread and vice versa. A synchronous queue does not have any internal capacity, not even a capacity of 1. You cannot peek at a synchronous queue because an element is only present when you try to remove it. You cannot insert an element using any method unless another thread is trying to remove it. You cannot iterate as there is nothing to iterate. The head of the queue is the element that the first queued inserting thread is trying to add to the queue. If there is no such queued thread, then no element is available for removal and poll will return null. Synchronous queues are basically used for handoff purposes. Synchronous queue example. We'll be implementing a producer-consumer example with synchronous queue. We'll be creating two runnable, one for producer, another for consumer. We'll be creating an array of string names and producer will put them in the queue once consumer is available to take them one by one. Put must wait for corresponding take operation. We'll be running this using executor service. Now let's implement this example in IntelliJ. Now let's create a class, new Java class, and the name of the class is synchronous queue example. Synchronous queue example. So let's create public static void main, and inside public static void main we'll be creating a string of arrays. String array and names is equal to first name is Mike, second name is Syed, third name is Jean, Jenny, Rajiv, and Henry. Now let's create an instance of synchronous queue. Synchronous queue, and this synchronous queue is for type string. Let's call this queue is equal to new synchronous queue. Now let's create a producer runnable. Producer is equal to and inside this producer we'll be looping through the elements within the names and we'll be putting them in the queue. For a string name of names and queue dot put name. And while we are putting the name, we'll be sleeping. Let's first print out inserted plus name in the queue. And let's sleep. So time unit dot millisecond dot sleep. And let's round them by try catch. So try and then catch exception or interrupted exception IE and IE dot print stack trace. Now let's implement our consumer runnable consumer, and consumer is equal to semicolon. And within the consumer we'll be looping forever while true and here we'll be sleeping for 2 seconds. So time unit dot millisecond dot sleep for 2 seconds, and let's print out. Retrieved and plus q dot take. So we are calling the take inside the system out so that it can print out the name directly in the system out. And then afterwards we are sleeping for 2 seconds. Let's run this with try and catch. Catch interrupted exception, i.e. I dot print structure. So here let's put the braces, and within the braces let's put this. Now let's create our executor service and run them, and then run these two threads using executor service. So executor service is equal to executors dot new fixed thread pool of size 2. And executor service dot submit producer, and executor service dot submit consumer, and afterwards executor service dot shutdown. Now let's look at our implementation. So we define the names of a string, then we create an instance of synchronous queue, and inside the producer we are looping through the names. We first put the name in the queue and then print it out that inserted the name in the queue, and then we are sleeping for 1 second. Here in the producer we are sleeping for 1 second because producer will be putting its first value at 1 second, but consumer will be sleeping for 2 seconds, so that we can see that the producer cannot insert the value until consumer is ready to retrieve it from the producer of the queue. So now let's run this example. So retrieve for Mike from the queue, inserted Mike in the queue. So you can see that inserted and retrieves are all in the sequential order. So you have to insert first and then retrieve it, and then wait for so until the consumer is ready, because consumer is sleeping for 2 seconds. Let's make it like 10 seconds here, so that it will become more clearer that producer cannot produce a message until consumer is ready. So it first inserted Mike in the queue and then retrieved Mike from the queue. Now consumer is not ready, so it cannot put the message in the queue. So once consumer is ready, it waked up from the sleep, then it inserted, then at that point producer can insert Syed in the queue, and then consumer is ready to take the message from the queue. So until in the synchronous queue, until consumer is ready to take the message from the queue, producer cannot put the message in the